Hello, it's Jolly again. I know you're getting really tired of me saying that. All right, this is the last video for the alkenes and the alkynes. And there were two reactions for alkenes. I didn't know where to put anywhere else, so I'm going to do those really quickly. But then I'm just going to do some practice problems. So the two that I need to get in here are, come on. Well, there. These very last two. Okay, the allylic bromination. I didn't put it up with the other halogenation problems because technically it's a reaction from next semester because it's a radical reaction. But I wanted to put it here because it will put a bromine not on the alkene technically, but one carbon away. So it's called allylic bromination. And then sulfonation is just another way, or if you will, a midway step to the alcohol formation, which we talked about. So this one, where are we at? This one should be up there, but it's, if you will, a halfway step. So I wasn't even sure, should I actually tell them? But it's a good one just to have a reference of. All right, so I think I'll do the sulfonation step first. When we were doing, get this cleared. When we were doing the addition of the alcohols to the alkenes, hydration, I gave you these conditions. Okay, nice and generic. And we would mimic a Markovnikov alcohol, watch out for rearrangements. Well, if you specifically use sulfuric acid, you can, okay, tongue in cheek, actually stop by putting the HSO4 on. All right, so the mechanism for this one is the exact same. You make the carbocation. The difference is, do you see that the conjugate base is competing with the water? So this could actually attach, and it's the oxygen that attaches to it. And you could make okay, so I'm trying to show that it actually attaches to the oxygen. All right, is that a useful product? I don't know, but it is a stopping point if you can. Okay, so you can try and stop right here. Use temperature, do something. You can try and stop right there. But if there is any water, excess water, or maybe a little bit of heat around, it's very difficult to stop it from continuing on to the alcohol. So the reason I didn't put it up there with those is, well, technically it's just hydration. Just you use sulfuric acid as your acid, but I needed to point out that yes, technically you can stop by connecting that sulfur group to the alkene. So there's one reaction. And the other reaction is called allylic bromination. Now, I will be talking about this one more in the second semester, but if I give you that alkene, remember, one away from it is called the allylic location. Well, what if you want the halogen on the allylic location, not actually on the alkene? We're going to use some conditions that are radical, NBS, and light is one way to get a radical reaction going, okay? Or you could use diatomic bromine and light. The key here is, yes, it's diatomic bromine, but this isn't just the halogenation reaction that I gave you before. This one is radical. And so it would put it in the allylic location, All right. The only reason I pointed those out is it's just two more in your arsenal of reactions, and I just wanted to make sure that you got to see those. All right, now the fun part. Let's do a review. All right, all alkene and alkyne reactions. As you went through each of these videos, you probably said, oh, yeah, okay, that makes sense. No big deal. They were probably fairly straightforward. The problem comes when suddenly you have to choose between them, or, oh, what am I supposed to do? Is this an alkene? Is this a whatever? So it's just nice to have some practice problems. So here, we're just going to randomly choose a few, and I'm going to talk you through how to figure out what you're supposed to be doing. All right, so let's say, well, you know what? Before I do that, I think there are three different types of reactions. There's ones that have missing products. Those are the ones that I have been doing all this year for your reactions in lecture. Here's the reactants, here's the conditions, you give me the products. So I don't want to say the easiest, but those are the ones that you're most common with. All right, what if it's missing the reagents? Or last, what if you are supposed to make the product? All right, so A plus B with some kinds of conditions is a question. Okay, so that's the generic first one. A plus B makes C, and you tell me what conditions. Or last but not least, hey, make me C. And sometimes I could give you the conditions, or I could just leave that completely blank. Okay, those, if it's completely blank, retrosynthetic analysis, where you have to think backwards, okay, those are probably the most difficult. So we're going to try just the first two to start with. All right, let's take this and let's make that one. All right, step number one, always identify what you do have. All right, over here, I have an alkene. Now, you're not going to be able to remember every reaction right now, but it's nice to have a file pop open in your head and go, okay, what do alkenes like to do? Well, alkenes like to do addition. And then the other things we learned were oxidation. Okay, it's pretty generic, but at least I put something down. Now, I didn't tell you the conditions, so I need to go over here. And I need to ask, what did I do? Okay. What was done to it? And if you'll notice, the alkene is missing and two things were put in its place. Okay, so the alkene is missing and two things were put in its place, so this was addition. And I can go one step further and say what was added? H and Br. And now we can either mechanize this or we can recognize it, but that looks like hydrohalonation. Oh, that's just HBr. And then I have to ask myself, is there anything special? Do I have to have any special conditions to this one? And if I look back on my reference sheet, the answer is no. I'm looking all the way at the top above the alkenes where it says just HX. And it says Markovnikov alkyl halide. Now, Markovnikov didn't matter in this case, but that one was just hydrohalogenation. All right, let's try another one. All right, step number 1, identify what you do have. All right, this is an alkyne. What do alkynes like to do? They like to do addition, or they do oxidative cleavage. All right, well, what did I do? Oh, look, this is 1 carbon, 2 carbons, and 3 carbons. This one only has 2 carbons, and this is 3 carbons, and so we must have done oxidative cleavage. And now the question is, what can we use? Okay, what could we possibly use on an alkyne to do oxidative cleavage? And did I try and stop somewhere? Are there any special conditions? All right, was I trying to be selective or is it just generic? And in this case, I'm looking now under my alkyne chart. Eventually, these are just popping up in your head. But if you're looking under your alkyne chart, oh, it doesn't matter. I could use potassium permanganate or ozonolysis because there are no special conditions. It will go to this regardless of what I do if it's terminal. And so I could use ozonolysis or potassium permanganate. Or you could be more specific and actually tell me the conditions. Whoa, that was supposed to be a capital. The nice thing is, unless I'm specifically asking you for the reagents, I am perfectly happy with you putting the word, oh, I recognize it, it's ozonolysis. Oh, I recognize it. Technically, this is what you should write. But you have your reference sheet, so when you say ozonolysis, well, I know you're talking about that. So technically, you should actually write the conditions. But if you do write just the word ozonolysis, I will know what you mean. Okay, let's do another one. Um, All right, how about that one? I have an alkene. What did I do to it? I must have done addition. And remember, there's a lot of different kinds of addition. Did I do syn addition? Did I do anti-addition? Did I do Markovnikov addition? Did I do anti-Markovnikov addition? Did I just do some old generic addition? All right, it helps if you can specify. So yes, it's addition, but can you dig into it and look for any details? In this case, there were 2 different locations. This one was a tertiary. This one was a secondary. So this has the term Markovnikov and anti-Markovnikov. So if you had added here, you would have called that Markovnikov. And if you had added there, it's anti-Markovnikov. So I know that I did an anti-Markovnikov addition of OH. Oh, how can you do an anti-Markovnikov addition to get an alcohol? So again, you go to your reference sheet, and the only one that can be anti is hydroboration. And again, to be technical. And let me see. So this is hydroboration. So the second part is H2O2 and water. All right, what if it had been this? I would have said, yes, it's addition, but this one is Markovnikov addition. And I would have looked at my reference and I said, oh, I could use hydration or oxymercuration, demercuration. And if I want to use this one, I can't worry about rearrangements. And in this case, I don't have to worry. So I could have used either of those two. Either of those two. Or the reaction I just gave you, you could use sulfur or sulfuric acid and a little heat. But again, hydration is probably the one that will pop into your brain. Oh, okay. I hope this isn't looking too horrible. Now remember, I am pulling all of this from memory. You're going, and that's why I'm giving you the sheets, is it's more important to recognize what's happened than just being able to spit some kind of, reaction at me. I want you to be able to say, if I want to make an anti-Markovnikov alcohol, there's the key right there. Okay, you could go online and you could research how many ways are there to make an anti-Markovnikov alcohol. The key is that you recognize that's what you were trying to make. And I've just given you a mini list of reagents. All right, let's do another one. Alkenes and alkynes. What else have we done? All right. Oh, look, I have an alkene. What do alkenes like to do? Well, they like to do addition, and then you can also do oxidation to them. So what did I do? Well, this looks like addition. Aha, now dig into some details. What did you add? Okay, you added diols. Okay, so you added 2 of them. And then how did you add them? This is syn. They went on the same side. So I've just answered the question. Hey, what did you do to this? Oh, I made syn diols. All right, well, what conditions will get you to syn diols for an alkene? And then you go to your reference sheet, or one day, hopefully, it'll just be in your head. Oh, I could do ozonolysis or KMNO4, but I'd have to control it with cold. Okay? Oh, I know I'm making this look really easy because I have, that whole arsenal just at the tip of my tongue. And all right, I have an alkyne. What did I do to it? Okay, I broke the pi bonds. I added, okay, what did you add? 2 bromines. Okay, and don't forget, every time you break a pi bond, you will have to put 2 things on. And so that's 2 of them. You also put on 2 hydrogens. Oh, so what did you add? Hydrohalogenation. That's what we did. Oh, you go back to your reference sheet and go, how do I add hydrogens and halogens? And because it's bromine in this case, it's that. Compare and contrast. Aha, what did you add? You added 4 bromines. And so you don't say hydro, you just say halogenation. And you look up the conditions, and this would be diatomic bromine. And then, some solvent. Carbon tetrachloride is the one that I use the most. Now, the nice thing about doing it on a video like this is you can pause and you can try and come up with the answer before you listen to my explanation, which is why I like doing it this way. Let's see, another one. Oh, look, it's an alkyne. What did you do? Okay, I lost the pi bonds and I gained a carbonyl. All right, that might not be prompting your memory yet, but when you break both of these, okay, what is a carbonyl from an alkyne? Remember, it could be an enol. Oh, what did I add to this? I added hydrogens and alcohols. Oh, this was basically just adding an alcohol. How many ways can I do that? Well, I could just do hydration, or I could do hydroboration. And what is the pros and cons for each? Hydration will never give you a aldehyde, it will only give you ketones, where hydroboration can give you aldehydes. And in this case, oh look, I needed an aldehyde. So you can't do hydration, you have to do hydroboration. Compare and contrast. The same thing, but you made a ketone. So because it was terminal, okay, because it was terminal, you can't use hydroboration because that would have given you an aldehyde. So you're going to have to use hydration. Okay, not done yet. Another compare and contrast. All right, we have an alkyne. We did some kind of carbonyl, so I did some kind of an enol reaction, and I ended up with a ketone. But this was internal, so I didn't have a choice. Okay, no matter what I do, I'm going to end up with a ketone. So use hydration or hydroboration. It comes down to those nitpicky details. Okay, I gained an aldehyde. All right, that is a selective condition. So I need to look at what are the pros and cons of each of my reagents. I chose a ketone over an aldehyde. That is a that is a specific selective condition, okay? But here, okay, there is no selectivity. So I can choose whichever one I want. Okay, this is the fun part now. You're probably not thinking so at the moment, but you have a huge amount of knowledge, and now you get to use it. Let's see. All right, it's an alkene. Alkenes like to do addition and some kind of oxidation or reduction. But in this case, what did you add? I broke the pi bond, so I did addition. What did I add in its place? Two bromines. How did I add them? I added them anti because one is wedged and one is behind. So I did an anti-addition of halogens. So guess what? I did halogenation. And I need to check, do you have any conditions that will put halogens on in the anti-location? And the answer is yes. Halogenation. Halogenation. All right, I know I'm making that seem very simple, but it comes down to just playing with the different, problems. This is the most important part, talking through what did happen so that you can go back and figure out, oh, what would be the best way to do this? When I went through, it was all about memorization. So I would look over and go, oh, yeah, there's two bromines. And I didn't even go for the details. I didn't go for the reasons behind it. And then I would just go, okay, which reaction have I memorized that puts two bromines on? This is the ultimate goal, is understanding what you did and then going to find a reagent that works. All right, now I've done a whole bunch where we're picking out the reagent. Let's now go to the hardest variation. All right, so I'm not even giving you any starting material, okay? I'm not even giving you any starting material. How in the world could you make, okay, now here's about the details. What in the world did you make? Yes, you made a secondary alcohol, or you could also look at it as you made the anti-Markovnikov alcohol. What else? Unfortunately, to me, that's the two that jump out. But what I'm seeing here is I could have done some kind of a substitution reaction. Okay, to make that secondary alcohol, or I could have done some kind of an addition to create the anti-Markovnikov. And guess what? Both pathways work. I mean, this one's better because this is hard because it's a strong base. Okay, details, details, details. But it's talking through how to get them. Okay, those are the absolute hardest problems. One way that I make it easier, at least at the beginning, is I give you at least one piece. So let's say I gave you that. Okay, that would be like what the one that we did just a few minutes ago. But I could have also done this. Oh, what is this? Okay, what are those conditions? Those are hydroboration. This is an anti-Markovnikov alcohol. And now the question is, what functional group do I need to use to get an anti-Markovnikov alcohol from hydroboration? And the answer is an alkene. Okay. So no help is the hardest, called retrosynthetic. This one, I'm just giving you the reagents and the products, and you just work backwards and give me the starting material. All right, that ends the reactions of alkenes and alkynes. And for us, the end of the first semester of organic. So good luck. Remember, you can always contact me. We can go through just different reactions. And I will see you later. Jolly out.